Hey guys, Mr. Backward here. In this video we're going to look at approximating solutions to inequalities. As inequalities get more complicated, they get more difficult to solve. So a lot of times what we end up doing is using some sort of technology to help us out in solving them. So what we're going to do is take a look at this cubic inequality and we're going to use our calculator to help us solve it. So we've got the inequality x cubed plus 2x squared minus 1 is greater than or equal to 0. I've got that left-hand side of my inequality typed into my calculator. So then we're going to graph this out. Now looking at this, we can see that there's at least two x-intercepts. There's two places where our graph crosses the x-axis. I'm actually going to zoom in on this a little bit though. So I hit my zoom button. I select zoom in, and then I'm going to zoom in right on the origin. So I want my cursor to be on the origin, and I'll hit enter. And this gives us a better idea of what's happening. We can actually see that there's three x-intercepts. So what we want to do is we want to figure out where our equation is equal to 0 by identifying those x-intercepts. So I'm going to hit second and then trace. Remember, another name for an x-intercept is a 0, so I'm going to pick option number 2 in here. Now there's three of these things, so we're going to have to find each one separately. So I'm going to start on the far left-hand side. It's asking us for a left bound point, so we want to make sure that we are on the left-hand side of our first x-intercept. Hit enter. Then we're going to arrow over to the right just past the x-intercept. Hit enter again, and then we can take a guess, but we don't need to. We can just hit enter one more time. So our first x-intercept is at about negative 1.62 if we round that off. Then we're going to go through and find our next x-intercept. So I'm going to hit second and trace again. We're finding another 0, so I'm going to pick option number 2. This time I'm focusing on this x-intercept, and it looks like it's happening at about 1, but let's confirm it just to be sure. So we get our left bound point, hit enter. We get our right bound point and hit enter. Again, we can take a guess, but we don't need to. We can just hit enter one more time. So that x-intercept is in fact at negative 1. And then we've got one more x-intercept to find. So I'm going to hit second and trace one more time. Option number 2. Now we have to be over by the last x-intercept. Again, it's going to ask us for a left bound point. So I click left a few times, hit enter, click to the right and go past the x-intercept, hit enter, enter one more time. And it looks like our last x-intercept is at about 0.62. Now remember, our inequality said that we wanted to be greater than or equal to 0. So being greater than 0, remember, means we are above the x-axis. So we're looking at the portions of our graph that are above the x-axis. And there's two places, meaning that there's going to be two intervals to our solution. There's this chunk between our first two x-intercepts, so between that negative 1.62 and that negative 1. But then there's also this chunk on the right-hand side after our 0.62 x-intercept. So if we're looking at writing out this solution in interval notation, remember we said we were above the x-axis between our first two x-intercepts, so between negative 1.62 and negative 1. Our inequality does have the equals to line underneath it, meaning that these end values are included, so we're going to use square brackets there. Then there was another portion of our graph that was above the x-axis, and that happened after 0.62. So 0.62 gets a square bracket around it. And then everything after that takes us out to positive infinity. That's going to get a parenthesis around it because infinity always gets parentheses. So that's how we can use a graph to help us solve a more complicated inequality. That's going to be it for this video. Thanks for watching.